So in our last video, we were dividing polynomials where you were given a specific expression and we were trying to find out if that expression was a factor. But we already had a starting point. We knew what factor or potential factor we were attempting to try. But now what if we didn't know where to start? What if I just had a polynomial x cubed plus 4x squared minus 3x minus 18, but I didn't have a starting point? I didn't know what values to look at to figure out where my factors are. So this activity is going to kind of walk you through that process. Like usual, I would like for you to attempt it on your own first. Press pause, try it, and then come back. But you do you, and if you'd rather just keep on watching, then just keep on watching. So part A is asking us to list the factors of the constant term. So our constant term, in this case, is 18. All of the factors of 18 be 1, 2, 3, 6, 9, and 18. But I have a negative here, so it could be a positive times a negative. Well, most likely that's the case, but if this had been a positive here, I could have had like 2 negatives, or I had 2 positives. So when I say these are the factors, I don't know if it's the positive or the negative of each one of these numbers. So I'm going to put a plus and minus out front. Okay. So then we want to list the factors of the leading coefficient. Our leading coefficient is the number in front of our highest degree, or our highest exponent number, term, I should say. So our leading coefficient is 1. So factor. So that one's not too bad. If that number had been a 2, I would say plus and minus 1 and 2. So find the ratio, all the factors of your answer in A over your answers in B. So what that means is I'm going to take my factors of 18 over all of my factors of 1. Now, again, 1 is just 1. So I'm going to say 1 over 1. So plus and minus 1. 2 over 1 is 2. 3 over 1 is 3. 6 over 1 is 6. 9 over 1 is 9. 18 over 1 is 18. If we had had a leading term of 2, for example, okay, so your constant term was 18, but your leading term was a 2. So I would have the same, like plus and minus 1, 2, 3, 6, 9, 18, and then I'd have plus and minus 1 and 2. So if that were the case, then when I say the factors of all of these over 2, I would have 1 over 1, which is 1, 2 over 1, which is 2, 3 over 1, which is 3, 6 over 1, which is 6, 9 over 1, 9, 18 over 1, which is 18. But then I would also take all of these numbers and put them over 2. So I'd have 1 over 2, which is 1/2, 2 over 2, which is 1. I already have that. 3 over 2, so 3/2. 6 over 2, which is 3, I already have. 9 over 2, I don't have. And then 18 over 2, which is 9. So that's how I would list all of those. But our example didn't have a leading term other than 1. So basically just the factors of 18 became the factors of my ratio. Okay. So all of these are the potential roots or zeros or factors, solutions of our polynomial, okay? And in general, we call these different values. So in general, we're going to call this P, and this one Q, okay? So these are factors of Q. And so when we want to write all the possible solutions, we say all the factors of P divided by Q. And that's going to be the numbers that we plug in here to see which one works. Okay? So I've got to see which one of these values that I want to try. So I put some extra boxes here for you to test out different ones. If it doesn't work, just go with the next box. So for example, I'm going to start with just x minus 1. Okay? I'm going to see if positive 1 is an intercept or a root or a solution. So my original polynomial is x cubed plus 4x squared minus 3x minus 18. So I'm going to put an x cubed right here. Okay, x cubed times x is going to be x squared. So then multiply the negative 1 times x squared and get negative x squared. And then I'm supposed to have a 4x squared here. So to cancel the 4x squared, I'm going to need a, let's see, I'm going to need a 5x squared. So then 5x squared and negative 1x squared, yep, that's 4x squared, we're good. X into 5x squared is going to be 5x. And then minus 5x down here. I'm going to have a negative 3x and a negative 5x. So that means I need a positive 2x here. So then x into 2x multiplies by 2. 2 times -1 is -2, but that is not the same thing as -18. So because this number is not -18, I know that x minus 1 is not a factor. So let's try, I like to stick with the small numbers first if I can. Let's try x plus 1. So then x cubed goes here again. Here I'm going to rewrite my polynomial so I can see it. I've got x cubed plus 4x squared minus 3x minus 18. So, okay. X cubed, x squared. So I've got positive x squared, positive 4x squared. So this is 3x squared. So 3x squared and x is 3x. And then, let's see, so 3x times 1 would be 3x. I have a 3x here, and I need a negative 3x here, so I'm going to say negative 6x would combine to give me negative 3. So it means I need to multiply by a negative 6. So negative 6 times 1 is negative 6, still not negative 18. So x plus 1, no go. Okay, that one does not work. So what other number can we try? So technically, I've already tried positive 1 and negative 1 as my potential factors. So that neither of those worked. Oops, neither of those worked. So let's try positive 2. Let's see if x minus 2 is going to work. So then again, I'm going to have x cubed here. Negative 2 is negative 2x squared. I'm supposed to have a positive 4x squared with a negative 2x. So we'll try a 6x squared here. So that means I have a 6x up here. 6x times negative 2 is negative 12x. But I need a negative 3x. So I'm going to need to multiply, or no, I need to add 9x. So x into 9x goes 9 times. 9 times negative 2 is negative 18. Oh, here we go. Negative 18, negative 18. That worked out well. So that means x minus 2 is a factor. Yay! So then once you have the first factor, what type of polynomial is left? Okay, what type of You've got x squared plus 6x plus 9. How do we keep going from there? We factor, if possible. If you can't factor your quadratic, then from there you could use quadratic formula or completing the square. But I think this one works out really nicely where we can just say x plus 3 times x plus 3 gives me x squared plus 6x plus 9. So then the final factored form of our polynomial, we already found that x minus 2 is a factor. So x minus 2, x plus 3, x plus 3. Or x minus 2 times x plus 3 squared. So the whole point of this was to still do the division that we did on the first part of our notes, but now we're giving us a place where we can start our notes. Like, what kind of values do we look at? So again, let's look at the check your understanding. I'm sorry, not the check your understanding. Let's look at some notes on the back. So if the polynomial f of x, which this is just the general form of a polynomial where you've got your leading term and your highest degree, and then you count your degrees, count down from here all the way till, if you have one, your constant term. Okay, so if the polynomial has integer coefficients, every possible rational zero of f has the form of p over q, where p and q have no common factors other than 1, and p is a factor of the constant term, aka your last term, and q is a factor of the leading coefficient, a sub n, this term right here. So basically, you list out all of the factors of the last term, all of the factors of the first term, and then you divide them. And those are the terms that you test to see if they work in your division, okay? Go ahead and pause the video, attempt to check your understanding, and then hop back on here so you can see how you did. Hopefully you have done that. Welcome back. So our check your understanding, I first started with listing out all of the factors of 16. So 1, 2, 4, 8, 16, all the factors of 1, which is my leading term, and then all of the factors of p over all the factors of q are just the repeat of the factors of p. I tried x plus 1 first. It didn't work. I tried x minus 1. That one did work. So then once I factored it down, I had a quadratic that I could easily factor. So this is the factored form of the first one, x minus 1 times x plus 4 times x plus 4. Number 2, factors of 6 are just 1, 2, 3, and 6 over the factors of 1. So 1, 2, 3, 6. I tried x plus 1. Didn't work. Tried x minus 1. Yay, it does work. Again, you're back to another quadratic that you can easily factor to x plus 3 times x minus 1. I'm sorry, x minus 1 times x plus 3 times x minus 2. So that's all of our notes for today. If you have any questions, please see me in class. I also have this filled out and ready to go for you guys in Canvas.